Hi, this is Mr. Miller again, and this is video 3, more evaluation. We're going to take it to a little higher level this time. It'll be fine. Our first slide has 4 examples for us, and these examples have more than one variable. That's okay. Whatever the values the variables have that they're given, we put in for them. We substitute in. So here, the first expression is a squared plus b squared plus c squared. So we just got to put in the values for a, b, and c. So a is 6, so we could say 6 squared. B is -4, so I'm going to remember I have to use parentheses around it. Got to square that whole thing. And then plus c squared plus 3 squared. You put parentheses around there, it doesn't matter, but around the -4 you have to. Okay, well, by the way, this is a great way of showing your work. Rewriting the exact expression, but with the values in for the variables. Then we can grab a calculator and do it. This will be 36 plus 16 plus 9. And 52, 61, I believe you get 61. Hope I'm not lying about math. I try not to lie about math. All right, we have x plus 6 divided by y minus 1. For x equals 14 and y equals 3. So 14 goes in for x, 3 goes in for y. We have to remember that when we're doing division, it's the whole numerator divided by the whole denominator. So it's 20 divided by 2, which is 10. Okay, well, how about this guy? We have x is 5 and y is 2, so let's put them in. We have x to the third power, which is also what we mean when we say x cubed. Cubed is to the third power. So we have 5 to the third power times y to the second power, so times 2 to the second power, minus 6 times parentheses x plus y. All right, so now we just grab a calculator. We can do this. We have 5 raised to the third power times 2 raised to the second power minus 6 times parentheses 5 plus 2. And I get 458. All right, one more here. It's kind of crazy. We have m's, p's, and w's. Okay, well, let's put everything in. 3 times m, that's 3 times 6. I'm going to write it like that, times p squared. I didn't have to use parentheses there, but sometimes the easy way to show multiplication. Minus 2 times m times w. You can enter it just like that. 3 times 6 times 2 squared is 4, minus 2 times 6 times -7, end up with 156. Okay? So for this, it's just a matter of being careful. Write the expression with the values in it, and then grab a calculator and calculate it. All right. We want to make sure you have no fear of formulas or expressions like this. In the calculator, this is no problem. So formulas from geometry often have multiple variables. We have r, that's for the radius of the can. We have h, that's for the height of the can. But what we're trying to find is v is the volume of the can. This, pi, as you know, is not a variable. It's a fixed number. It's always 3.1415. Okay, I don't know the rest of pi. But pi is a constant. It doesn't change value. But these other guys do. All right, so like we said, the equation below is the formula for the volume of a cylinder. In geometry, we learn all kinds of volumes like this. We want to find the volume of the can of baked beans. Well, the radius, r, that's the distance from the center to the edge of the can, is 3.5, and the height is 11. So volume is going to equal pi, there's a pi button on our calculator we'll use, times the radius squared times 3.5 squared times the height times 11. Nothing to be afraid of. We just grab our calculator. You may have to find the pi button, but we're going to do this. Second pi times 3.5 squared and then times 11. All right, and we get a decimal approximation. It's about 423.3. In geometry, units are very important, and it turns out if these are centimeters, the volume would be centimeters cubed. Okay, so you don't have to worry about that right now, but length is measured in centimeters. Area, like the area of a square, would be centimeters squared. But if you have volume that you're measuring, okay, that's supposed to be a cube, it's centimeters cubed. Our goal here is just to be able to substitute for the variables and evaluate the expression. So if you got that, you're fine. Here's another one. This is a formula for the volume of a sphere. Okay, so use the formula to calculate the volume of a beach ball that has a radius 18. They told us exactly what we need to know, that the radius is 18 inches. So here's the volume. It'll be 4/3 times pi times 18 raised to the third power. We're going to get a decimal, it's okay. So to enter 4/3, you just do 4 divided by 3. We're going to times that by pi, and we're going to multiply that by 18 raised to the third power. And we get a big number. We get 24,429 approximately. We measure the radius in inches, so this would be inches cubed. All right, a cubic inch is not very big. There's a lot of those fit in that big beach ball if you blow it up. All right, well, time for the journal assignment. So we got a couple problems for you to try. You show them to your teacher. Good luck.